So let's look at tutorial sheet 6 question 2, which is about how to calculate the electric potential difference due to a point charge. So we looked at question 1 in my previous video, which was asking us on how to calculate the work done in moving some charges from a certain point or from a point of infinity. So we're going to move on to question 2. Now question 2 reads, 3 charges are at the vertices of an isosceles triangle with Q equals to 7 nanocoulomb. The 2 charges at the base of the triangle are separated by 2 centimeters and each have a charge of negative Q. So the charge Q at the top of the triangle is 4 centimeters from each of the base. Now the question continues to say, calculate the electric potential halfway between the charges on the base of the triangle. So to answer this question, you first need to draw a free body diagram which illustrates what the question is saying. So we have 3 charges here, and these charges, they are saying, are at the vertices of an isosceles triangle. So you draw a triangle, and you show these charges. So you name them Q1, Q2 and Q3 on the vertices of an isosceles triangle. So an isosceles triangle is a triangle with 2 sides equal. 2 sides are equal. Okay, so that is an isosceles triangle. Then from there, they have given us the distance. We have the distance from the top to the base, which is 4 centimeters, and these other 2 charges at the base, the 2 charges at the base there, they are separated by a distance of 2 centimeters. So you illustrate that. So the diagram is here. Okay, so we have these charges there on the vertices of an isosceles triangle. So after drawing your diagram, find the distances from the charges to the point of interest. From the charges to the point of interest, they are asking us to find the potential difference. Calculate the potential difference or the electric potential between the charges on the base of the triangle. So in between, halfway in between the bases of the charges at the base. So we have these 2 charges here. Now they're asking us to find the electric potential here at the point halfway. So we have the distance from this charge to the point of interest. So that distance is simply half of 2 centimeters, it will be 1 centimeter. And we have the distance from this Q2 to that point of interest, and it will be 1 centimeter. But the distance from Q3 to the point where we are required to calculate the voltage or the potential difference, we do not have it, so we need to calculate it first. So this distance, we can find it by applying Pythagoras theorem, which says the square of this side here plus the square of that side is equal to the square of this side here, meaning we are going to subtract this side here, which is 1 centimeter, from that 4 centimeter. Then the square root of that will give us the distance, this distance which we are looking for. And to do that, we are going to name the unknown distance to be x. So it will be just the square root of this 4, which is the hypotenuse there, because this will make a right triangle. So it will be just 4 squared minus 1 squared. 1 squared is 1 centimeter, half of 2 centimeter. So the square root of that will be the square root of 15, and then square root of 15 is 3.87 centimeter. So converting this in meters, it will be you just divide that by 100 and it will be 0.039 meters. So that is the distance from Q3 to the point where we are required to find the electric potential. So to find the electric potential at this point, we are going to use the formula V is equals to K multiplied by Q divided by the distance. So that R is the distance from the charge to the point where we want to find the voltage. So to find the voltage here, we are going to sum up the voltage or the electric potential due to this charge and electric potential due to this charge and electric potential due to that charge there. So we are going to use V, which is the electric potential, is equals to V1, which is the electric potential due to Q1, and V2 electric potential due to Q2, and V3 electric potential due to Q3. So since you already know the formula is K multiplied by charge over R, which is the distance, then our V2 here will be just K multiplied by Q2 over R2 and K multiplied by Q3 over R3. So from here you simply factorize, you factor out K, and then you are going to remain with the Q1 over R1 and Q plus Q2 over R2, Q3 over R3. But we know that this K is simply a constant, and it is just 9 times 10 to the power 9. And Q1, we already have it in the question. The charge we already been given, it was 9. The charge is 7 nano coulomb. So this nano here is simply 10 to the power -9. That is what that N stands for there. So, and the charges at the base are negative. They are negative when the one at the top is positive. That's why we have these negatives here, those negatives there. So our R, we said, is the distance, so we replace that in our formula. So the base charges will have the distance of 0.01 meters, and the one on top will have the distance of 0.039 meters. So punching this on the calculator, you must get these numbers here, and this is positive and these ones are negative because of the negative charges there. So multiplying that with this, we are going to find that our voltage will be negative 1.10 by 10 to the power 4 volts. So that's all in this video. Thank you very much for watching. Don't forget to like, subscribe, and leave out your comment concerning this video.